Today, I wanted to focus on being able to use the image that we get from the depth API to save that to our phone and then also be able to present it in 3D space. So we'll just kind of set an image up in the space so that we can observe the image that we've just taken from a particular position. So we'll be able to reposition and take another photograph. And so this will give us an idea of how the depth API works with multiple different angles. You'll be able to compare them, and that'll be really useful. So I think this depth capture is a pretty neat feature to have. You can make some really interesting images with it. It's also really interesting to see the contours, and you can really quickly build out some really neat textures and neat images that you can find. So I think it's a pretty neat thing to play around with. It's neat. I think converting the depth API into images is one of the easiest ways of interpreting the data. It's a little bit hard to actually get an idea of how good it is doing with meshes, although meshes are going to be very useful in the near term for some of the other projects I have in mind, but this particular one is very good for getting an idea of where the algorithm falls short and where it doesn't. And so it is not great at just hands and things that are singular objects, but it is really good for getting an idea of the structure. So it's better for architecture or things like walls and large objects that are very well defined, and it's not as good for skinny things that go through your scene. So if you had a lot of strings, that would not be good for it. And then I also wanted to be able to make contour maps. So if you take the depth and you segment it, you can end up with these really interesting contour maps that show the contours of your local environment, and they just look really interesting. And you can also get some really interesting insight into how contours work. So because we've been working with a similar skeleton multiple times over, I wanted to start with the interesting bits, and then afterwards we'll just fill in the skeleton that we've been commonly using. And so to start off with, we are going to start with what gets called on every single frame of our situation. So every time that there is a frame in AR, this will get called. And so we will get the depth information from the frame, and then we will see if we have a capture next flag. And so because this is a pretty intensive process, we just want to capture when we are actually taking an image. And so we'll have a flag that will be called capture next. And once this happens, we will set it to false so that it won't happen twice. And then we are going to go decide on the scale of our image. So what we want to do with the scale is convert it from the field of view. We're just going to do some straightforward trigonometry, get a scale from that, and then we're going to build out our planar geometry. And so this is what is going to be the thing that gets placed in our AR scene with the depth information. After that, we're going to convert our depth information into an 8-bit int array in JavaScript, and we are going to get a canvas. And so this is just an HTML canvas. We will add some of the traits to that canvas that is also in our depth information. So those are just converting values that we got from our depth. Then we are going to get the context from our canvas. We are going to remove the image smoothing. So normally canvases just automatically smooth images out. Since we're using a low pixel image, it will end up smearing quite a bit of the information. So we're just going to try and stop that from happening. Then we're going to create image data from the depth data and the depth width. The image data will be how we get our depth data into our image. So now we're going to create a capping function. And so basically what this does is it converts our value into meters and then caps it at 5 meters. So right now you can change this value, but it will cap the maximum value at 5 meters. And this also gives you an idea of how to convert between our values to the raw meters. So it will basically come in an image format, and then we have to take the two values from that image and convert them into it. Okay, so now to actually get it into our canvas, what we're going to do is we are going to use an RGB to HLS function, and that's because HLS is much nicer for visualizing to get to a similar brightness and similar type of color, but change the hue. And this is kind of how I prefer mapping out color, is by using hue instead of RGB if you need to differentiate by the color. Okay, and once we have all that, we can just put the image data back into the canvas, and then we can wrap that image in a texture, and that texture we can add to a mesh material and then add that geometry to a mesh. And then we're going to copy some of the information from the camera. So the quaternion, the kind of rotation, the position, and then we are going to just add an extra little bit to that position so that it's in front of us. And we will rotate that mesh so that it's aligned correctly. And after that, we will add the mesh. The next portion is how we're going to actually save the image. And so there's a bunch of different ways that you can do this. I don't know if this is the best way, but this is the way that I found to do it, is you can add the canvas to a data URL, you can create an element, and then you can add a download variable to that element, and then an href, and then you click it, and then you remove it. So that's how I found to do it. There's probably other ways. There's probably better ways. Seems like a really hacky way of doing it, but this is the way of doing it. Okay, so now we're gonna wrap this entire function, or all of this code in a function, and this is going to be our onXR frame function. And what we have to include with it is the rendering, some of the information about getting particular values. So we have our XR session, we're requesting a frame, we are having our pose. The pose is basically the position that your camera is in. We're getting the view from that position. We're getting a viewport that we're adding to the base layer. So then we will define some of our universal values. And now we're pretty much just good to add in a bunch of the extra stuff that we had lying around. So a bunch of this kind of boilerplate stuff we're gonna have. So we will add in some of our click listeners. So the things that change based on the clicks. And then just the bit boilerplate code that we always include, which is that AR function, the init function. And after all this is done, we also have to include the HLS to RGB. I got this particular function from Stack Overflow, but it's a pretty common thing that you can do. So you can look up how to do that. Also just a basic get canvas. This is a little bit of a messy thing. You don't need all of this extra code. I just always seem to have problems with canvases. So it's not necessary to make it this complicated. Okay, and then that's basically all that we have. So it's just a lot of boilerplate. We need to make sure that the XR frame is in the right location. And then there are some preferences that we need to change when we're calling our session. So we need to include the GPU optimization and the luminosity. The other two are actually currently not available. So those probably might break things in the future. But right now, it doesn't seem like the GPU one works at all. Okay, bye.